So elements are like the identity of the atoms. An element could be something like carbon or hydrogen, and every element has different characteristics and properties. So if I told you that we are going to look at some atoms, your first question should be, well, what type of atoms? Are they carbon atoms? Are they nitrogen atoms? Are they sulfur atoms? Because each atom of a different element will have some different properties. An atom is the smallest unit of matter that retains the properties of an element. So, for example, one carbon atom is the smallest possible amount of carbon that we can have. If you go any smaller than that, it's not carbon anymore. So, what's smaller than an atom? Well, there's something called subatomic particles. And sub is a Latin prefix that means below or smaller. So subatomic means something that's smaller or part of an atom, subatomic, smaller than an atom. And there are three subatomic particles that we will talk about in this class. We will look at the protons and neutrons. As you can see here, these are in the middle of the atom, and this forms what's called the nucleus of the atom. Now, don't get this confused with the nucleus of a cell. That's a very different thing. This is the nucleus of an atom. And if you look at the outside of the atom, you can see electrons. Electrons orbit around the nucleus, which means they go around the nucleus. So the protons and neutrons are in the middle, the electrons are on the outside. Now, how many protons an atom has, that determines the atomic number, and that determines the identity of that atom. So if you look at an atom and you want to know what element is this, well, you can count the protons. If you count the protons, that will tell you exactly the identity of that atom. An atom's mass number is the sum of the number of protons and the number of neutrons. So for example, if we look at this atom here, does anyone know what element this is? I'll let you check on your periodic table. You can figure this out. But this element has 2 protons and 2 neutrons inside of one atomic nucleus. So what would the mass number be? I want you to try to figure that out on your own. Add together the number of protons and neutrons. The atomic mass is approximately equal to the mass number, and in biology class, we can just say they're about the same. We don't have to worry about that too much. But something we will worry about is isotopes. So an isotope is a different version of the same element. And what makes it different is that it has a different number of neutrons. Now, it has the same exact number of protons because that's what determines the identity, but it may have a different amount of neutrons. For example, carbon. Carbon can be found in different forms. And in each of these forms, there could be a different isotope, which means that there are different types of carbon, and sometimes carbon has a different amount of neutrons. Let's look at carbon-12, carbon-13, and carbon-14. Carbon-12 has a mass number of 12 because it has 6 protons and 6 neutrons. Carbon-13 has a mass number of 13 because if you look at the neutrons, there's actually 7 neutrons instead of 6. So maybe you're thinking, well, wait a second, how can that still be carbon? Because look at the protons. The protons are always 6. If it has 6 protons, it's always carbon. The number of neutrons does not change the element. The number of neutrons just changes the isotope. So there's a carbon-12 isotope, a carbon-13 isotope, and even a carbon-14 isotope. If you're really curious about this, you could find out which type of carbon is most commonly found on our planet. And some isotopes can even be dangerous for us, but we also use isotopes to do different types of medical imaging. So you can see in this picture, we're using radioactive isotopes. That's cool.